Hi everyone, welcome to Leetcode Programming. In this video, I would like to discuss one of the problems from the weekly challenge, which is a week ago. The problem here is minimum initial energy to finish the given task. So as you can see, this is a hard problem, but once you understand the logic behind this, once you understand the examples, how the answer is calculated in the examples, it is pretty straightforward, so you can do it easily. So let's look at the problem description. You are given an array task where task of I will give you the information about the actual energy required to finish the task and the minimum energy that is required to actually begin the task. Let's say we have a task 10, 12. So the actual energy is 10. The minimum energy that is required is 12 to begin this task. So if your current energy is 11, you cannot process this task because you need at least 12 to start the task. So that way, if you have an initial energy of 13, you can process this task and you can finish. But for finishing the task, you just use the actual energy and you don't bother about the minimum energy. So this way, we need to process the given task in any order that we like, but we need to make sure that we use minimum amount of energy that is required at the beginning. So that we need to calculate and return the value. So return the maximum initial amount of energy you will need to finish all the given tasks. So let's see the examples. So we have 3 tasks. So the amount of energy that is required is 8. So let's see how it is calculated. So we start with energy of 8 and you process the third task first. So the minimum energy requirement is satisfied, so you can start the task and you are left with 4 after using 4. Then you start the second task because the minimum energy requirement is 4 here, and after finishing the second task you are left with 2, and similarly you process the third task. So 8 is good enough. So 8 is the minimum value. And in the second example, we have 5 tasks. So again, the output is 32. Let's see how it is calculated. So you start with the energy of 32 and you process the first task. You are left with 31 because the minimum requirement is 3 and the actual energy that you spend is only 1. Then second task again you are left with 29 after spending 2. Then the third task you are left with 19 after spending 10. Every time when you are processing the task, just observe that the minimum energy requirement is satisfied. And the fourth task, and you are left with 9 after processing. Then the fifth task, you are left with 1 energy. But anyway, it's fine. So you are able to process all the given tasks using energy of 32. So let's look at one example in detail. After that, we will go to code and we will see both solutions for both C++ and Java. So let's understand closely how we are doing this. Let's say we have this. If you see, the energy that you actually spend for all the tasks is 1 plus 2 plus 4, which is 7. And the minimum requirement here is 2 plus 4, 6 plus 8, 14. If you combine. So your answer will be somewhere in between. So you may not be able to finish with actual 7, or you don't need 14. So your answer will be somewhere in between. That will be the best minimum out of all the given possibilities. So what we can do is we can start with total energy. That is anyway we cannot go below this because you need this total energy to finish all the given tasks. Then we need to optimize such that we take a minimum energy on top of what is actually required, and then still satisfy the minimum requirement of all the tasks. So that is our aim. So let's see what we can do. So one straightforward thing is what we can do is we generate all the possible ordering of all given the task, and for every ordering you calculate what is the energy required to process this task, and then finally you take minimum out of all this. But that will going to definitely time out, so we need to come with a better approach. So if you see the constraints, the task length can go till 10 power 5, so we cannot afford any solution that is beyond O of n square, including O of n square. So we should come up a solution something which takes below O of n square, something like O of n log n, O of n log n, or O of n. So now Let's see how the second example is actually done. So we have these tasks. If you see the actual energy 1 plus 2 3 10 13 23 8 31. So you just need 31 to process all the given tasks, but there is a minimum requirement which is sometimes more than the actual energy. So considering that the answer here is 32, so let's see how we have come to this. So we process the first task, and we process all the given tasks. We are able to do it with the output of 32, but if you closely look at here, the first task that is processed is having a difference of, you just look at the difference between the actual energy and the minimum energy requirement. So here we have a difference of 2, here we have a difference of 2, and for all the rest of the tasks we have a difference of only 1. So the tasks are processed in the order that such that the tasks having more difference between the minimum and actual energy requirement are processed first, because at your hand when you start the processing task you have more energy, so you will be able to satisfy the tasks which are having more requirement in their minimum energy and the difference with the actual energy. So we need to process the task such that the task should be ordered in such a way that they will be in the decreasing order of the difference between the minimum energy requirement and their actual energy requirement. So that's what we are going to do in our code. So we need to first sort the given task, then in the once we get the order, we process one by one task and then see if we need to add any extra additional energy or to process any given task based on its minimum energy requirement. So let's look at the code for C++ first. So here it is. So first we are going to sort the given task, and we need to write our custom sort function because we are sorting a vector of integers, I mean 2 integers. And if you see here, we are having a1 minus a0 greater than b1 minus b0. So whichever task has more difference between their actual and minimum energy, they are going to come first. So that's the order that we want. Then we go through all the tasks, then calculate what is the minimum total energy that is required, because we need at least the energy that takes for all the tasks to process. So we just add the actual energy that is required for every task and we calculate the total. Then on top of it we need to add some more energy so that we satisfy the minimum energy requirement for all the given tasks and still end up with the minimum answer. So now we start with the total. So our answer will be total initially. Then for every task we have to check. So when you start so the total will be having the current total energy we have at our hand before processing any task at that particular task. So for any task, if its minimum energy is more than the current total, we need to add the additional energy that is required. So we add the difference, the task 1 minus total to the total. So we increase our total energy so that we can satisfy the current task. And then after processing every task, you just remove the energy that is actually spent for the task. And finally you are left with total value which is additionally added for some of the tasks where there is a minimum energy requirement which is not satisfied using the current total. So that we are going to add it to our total actual total. So initially we are having a result of total, then we will add the additional energy that we have added while processing these tasks, and that will be our final answer. So let's execute and check. Let me delete this column. Yeah, it works fine. So let's submit and check. Yeah, so the solution has been accepted and every test case has passed. So it has a runtime of 936 milliseconds, so almost a second. So let's look at Java solution. So it's pretty same, except that the sort function will be a little different. So here, as we discussed, we are again sorting the given tasks in the descending order of the difference between minimum energy and the actual energy. So this is the custom sort that we are writing for Java. So arrays.sort, then b1 minus b0 minus a1 minus a0. So here in Java, the sort function will sort the given task in such a way that if you return a value less than 0, the first task will be placed first in the sorting order. So if you return a value greater than 0, the second task will be placed first in the sorting order. So if you return a value 0, so it keeps the same order. So here we want the task having a bigger difference between the minimum and actual energy in the order, and it should be in the first in the given order. So we make sure that b1 minus b0, if it is greater than, if this is greater than this value, then b is going to come first, otherwise the order will be same. And again we process all the given tasks and we calculate the total energy, and again we start with the total as our result as total, then we process every task and check if it needs any additional energy to satisfy the minimum requirement, then finally return the answer. So let's execute and check. Yeah, it works fine. So let's submit and see the runtime. Yeah, so 22 milliseconds and it's faster than 70%. So let's look at the runtime complexity. Let's discuss about that. So as you can see, runtime complexity is same for both C++ and Java. So we are using a sorting here. So it ideally takes of n log n, and we are processing all the tasks here. So it will be in the order of O of n, and again we are processing the task again. So it will be again in the order of O of n. So it will be O of 2 of n or O of 2 of n plus O of n log n. So ideally O of 2 of n, 2 is a constant, so it will be in the order of O of n, but O of n log n is more than O of n, so the overall time complexity will be O of n log n, because we are using sorting. So remember that whenever we use a sort function, the time complexity will be O of n log n, and unless you do something extra, the time complexity is going to be same. So that's it for now. Thanks for watching. Please do provide feedback and please do subscribe. Thank you.